All right. Hello, everyone. My name is Vladimir Valouch, and I'm here today to speak about Kotlin introduction and especially Lambdas. So let's start with a basic introduction or explanation why we are even going to speak about Lambdas in this course or in this session. The reasoning for it is relatively simple. You will bump into it while using Kotlin for development of Android applications pretty much everywhere. If you do not believe me right now, I'm quite sure you will believe me right after this session, where I will really try hard to show where are the typical places where the Lambdas are used in Kotlin and in Android development. In the beginning, what I'm going to do, I will just create a tiny method which will help me keep the code relatively clean. Here, this is Android part, so I don't want to add there that much stuff so that it's not mixed together that much. So I will create my function, which will be called Lambdas lesson. It will be empty, and it's just something what I'm going to call each and every time when I start my application. Here, what I will do, I will try to show you how to define a first Lambda. Let's call it my first Lambda. I will create val, as we said previously, it's a final variable into which I'm going to store my first Lambda. My first Lambda will do nothing less than just print the log statement once I call it. So let's, as usual, rather check that the logging is here. Okay, it's here. And normally I would need something like a tag. I will create my tag. This is just this basic setup that I will be using so that I do not need to type the tag again and again and again. Tag, and this will be this way. I have defined this is the Lambda, which I have assigned in here. If I would like to see what the Lambda in progress or why it's working, this is the way how I can call it. There are actually two ways how to call the Lambda. Once you define it this way, you can call it just by adding the brackets, or you can use my first Lambda dot invoke. Both approaches are absolutely equal, though I would strongly recommend to use just this first one. It's simpler, it's faster, it's less coding. So let's run the application. Application will start, hopefully. And again, I'm using a logcat to look at the logs. I will add my tag in here so that I'm filtering just the output that I want to see. You see that I'm outputting main activity and I see hello world twice. So this code was already called twice, which is great. Let's add here. This is one way how to define Lambda. If I won't be deleting, I will keep it here and I will just add. I will create my second Lambda. And this one will be pretty much same. Just I will try to show you something extra. We are currently going to have a look at declaration and returning from the Lambda. We will start with the type declaration, and we will use actually, we will create now multiple Lambdas. here you can think, oh, but this is absolutely the same as the previous one. You know what happened here? Kotlin happened and it's type inference, which is something absolutely beautiful and super useful to us. Normally, if the type inference would not be there, you would need to write something like this, that this lambda is actually a function where the return type is NA, or in my particular case, unit. It means nothing. Now I can again call my second lambda, and we will see that it should be still running. It is not crashing, but this time I have defined what exactly the type is. Let's run it. We should see hello world 3 times and hello world 2. All right, this probably was too simplistic. So let's try it on something more in depth. So I will create my third lambda. And that one, I will define in a little bit different way. This time, I'm going to create a lambda, which takes as an input integer and outputs also an integer. With this one, we are also going to practice 3.2, returning from lambda. So you see that I am defining that I will try to obtain something. Here, the easiest way is just to write, I'm getting on as an input number, and I will, for now, I can just return the number, or I can even multiply it by 2. It does not really matter for me. Let's see if it's true. Again, I will write just stack and output it. So output of third lambda 4 equals, and we are still using pretty much the same thing which we shown previously. I'm still outputting the logs I'm still outputting into the logcat. And here you see that I'm calling it the exactly same way as previously. So if I run it again, nothing is crashing, hopefully, and I should be able to see the output. Of course, I could name this as a multiply by 2 or multiply by 3, and then it would make even more sense. Now, this way, we can see that all I have to do in a lambda is pretty much just write the code, and the last line, which is executed in the lambda, the result of the last line in the lambda will be returned. So I do not need to type anything like a return. It's just will go back, which I believe is super useful. Step number 4. We might want to be able to create extension lambda. I'm sure that we were not speaking that much about extensions yet. I will try to show it to you. Extension is function which is extension function is a function that is bind to a specific type. Here I will show it on example with the string. So I hope it will show that it will show more. And I will create my appender. Again, I'm going to do the definition. So again, I'm creating a final variable of a name appender. And what I'm going to define here is the object to which it will be bound. And I'm also providing the information about what will be returned. So here you see that appender can be bound or bind to a string object. It will take no input otherwise, and it will return the string again. What it will append, it's actually up to us. So here I will show another nice thing is that I can use it. If you do not name the variable as a number, the default is it. Should work. Yeah, because I do not have the input. This. With this word, I'm actually referring to original string to which I appended. So let's see how it would work. Again, I have my logging here, and I can rewrite the whole thing. And what I will provide, I can even show it here as a result. Or no, I'll just log it here. Action. And I'm going to create my text here. Open dot. So after this line, I should see open appended, or this could be again world number 3. Hello. And I do not need to place here this. And if I run it, I should see hello space world number 3. So I took this hello, which is of a string. I created extension lambda, which is defined here, and I call it on it. So you see, I obtain hello world number 3. We're going to do a tiny introduction of the closures. So step number 5 is closures. Here as a base, I will create some list, or yeah, I will just call it my list, and it will be a list of integers. Actually, I do not need to define the I do not need to define the type because, again, Kotlin and its inference will figure out just from the variables that I passed in. I have my list, and once I have my list, I can actually use already predefined functionality which is there in Kotlin. Here I will use as a nice example map. As you can see, it's written in very similar way. I'm just passing in. I'm just going to pass in what should happen with the data. Here you will see that I'm going to use it, which I've previously mentioned, and this it will be reflecting, or it will be mapped to each and every element. So how the map works, it goes one by one, where during this iteration, each one of them can be referred as it, and I can do something with it. So if I can do it times 5, I will obtain a list times 5 list, and here I have my list. Again, I will quickly show it in the logs. Run it. See it. Well, everything timed is there times 5. Last but not least is actually passing functions. Here I will start with really trivial setup test, and the test will take in my function, which is of a type of this type. Is returning nothing, and the only thing which I will do inside is that I will call my function and execute it. Normally in the code, if you would be using it, you would write something like test, and if you are not aware of the beautiness of Kotlin, you would try to write this, and here you can put hello world. Though Kotlin itself allows you to do this beautiness, which is just test. And here you can pass your hello world. The output of those two will be exactly the same. It's hopefully also explaining why the map right now looks like this. Normally it would be a map where I'm inputting a method or lambda. But thanks to Kotlin, I am able to define the exactly same thing this way. With that said, we are at the end of this lesson. I will stop the recording and definitely provide you space for asking questions.